Video we are going to solve this convolution sum, right? X of n convolve with h of n, where x of n equal to 2 to the k u of negative k, and h of n equal to u n minus 2. So we solved this question analytically, so I wanted to show you how you could do this graphically as well. So in this video we are going to follow the steps, a few steps to do this correctly. So we have y of n, which is equal to x of k. So let me write the summation now. So sum k from negative infinity to plus infinity. Why do I put k here? This is n and this is n. So was ahead of myself. So x of k, then h n minus k. So in step 1, so we are going to sketch h of negative k and h n minus k. So let's put that in step 2. So step 2, we're going to sketch h n minus k. So in step 1, let's sketch I'm gonna move this down here. Can I sketch? So h of k, this is h of k. So h of k is u of k minus 2. So that's start at 2. Okay, so there. So this is 1, 2. So 0, everywhere else. That's h of k. Now, gonna sketch h of minus k. So h of minus k. So let's say this negative 1, negative 2, negative 3, negative 4, negative 5, and so on. So when we do the time reversal of h, so h negative k is time reversal. So start from here to minus infinity. Start from negative 2 to minus infinity. We negate the time axis. So all this are 1. Oh, there's no data point there, but this point is 1. That's what I meant. Okay, and a 0 elsewhere. So a 0 for n equal to negative 1 and above. So that's h of minus k. So what is h of n minus k? So in h of n minus k is this. Okay, so we're gonna shift this function by n. So let's say this is -1, -2, -3, -4, -5, -6. So then h of n minus k, then I'm gonna, so we have from -2, so we add n to all the time values. Okay, so the data will be here, right? It's just a sketch, n could be anything, right? So this is not at -2, specifically. Is just at the first value, right? Is n minus 2, and then a 0 as well. Okay, so this n is a variable, right? So -2 plus n could be anywhere. Now, so that's h of n minus k. So h n minus k. Now I'm gonna sketch x of k, which is 2 to the k u of -k. So that is going to be this. So when k equal to 0, 2 to the 0 is 1, then it's going to be k to the -1 is half, then minus 1/4 and 1/4, and so on. Okay, so that and the next one will be smaller and go smaller until we reach infinity. Now this is k and this is 1. Now we wanted to compute y of n, which is sum k from -infinity to +infinity, x of k, h n minus k. So what we're going to do for graphical convolution, I am going to sketch the x that we're not moving. So the x is right here. Okay. So that is x of k. And then I'm gonna sketch h of n minus k. So h n minus k. So I'm gonna put it somewhere. They are 1. So the first one will be n minus 2, n minus 3, and so on, n minus 4, and so on. So here we're multiplying these two functions together. So we are going to distinguish a few cases. So when So when okay, so I probably then those data points are 0, right? Those are 0. Okay, so the data stopped n minus 2, right, as we did above, right? I'm just copying this down there. So when n minus 2 is less than 0, right, that 0, I'm comparing n minus 2 to 0. So when n minus 2 is less than 0, then the summation run from negative infinity to n minus 2, because that's where the overlap happens. Okay, so then we have x, which is 2 to the k, and h is 1, right, times 1. So that is sum k from negative infinity to n minus 2, 2 to the k. That n minus 2 is less than 0. So this gives me, we know from the previous video, the summation formula. So when I have sum from a to b of alpha to the n, alpha to the k, then is alpha to the a minus alpha to the b plus 1 divided by 1 minus alpha. So we're going to apply that formula here. 2 to the minus infinity minus 2 to the n minus 2 plus 1 over 1 minus 2. So which is equal to 2 to the n minus 1 when n minus 2 is less than 0. Okay, so y of n equal to 2 to the n minus 1 when n minus 2 is less than 0. Now, what is the other scenario? So that's case 2 is when n minus 2 is bigger than or equal to 0. Then we have this scenario. So we have the x, which is 1, then half, then so that is x of k. And then the h is going to be this is n minus 2, n minus 3, n minus 1, and so on. Okay. So then when n minus 2 is bigger than 0, we compare that to this. Then what do I have? So we have n minus 2 is bigger or equal to 0. Then y of n is equal to sum k from, so the overlap is from negative infinity to 0, right? So you can see, right, that's where they both overlap. Okay, so 2 to the k, so applying our formula, add 2 to the negative infinity minus 2 to the 0 plus 1 over 1 minus 2. Right, we know that 2 to the negative infinity is 1 over 2 to the infinity, which is 1 over infinity, which is 0. Right, so that's why this is 0. So for this case, n minus 2 bigger equal to 0, y of n is equal to 2 to the 1, which is 2. Now let's put it together. We have y of n equal to 2 when n minus 2 is bigger or equal to 0, and 2 to the n minus 1 when n minus 2 is less than 0. Okay, so if you wanted to express this in terms of the unit step function, we can write this as so n minus 2 is strictly less than 0. That means n minus 2 is less than or equal to -1. Right, so if you look at the discrete time axis, right, we have, let's say this is 0 and 1, -1, -2. So n minus 2 is strictly less than 0. That means at most is going to be equal to -1. So that means n minus 1 is less than or equal to 0. R, you have -n plus 1 will be bigger or equal to 0, if you agree with me. Okay, so we can write y of n equal to 2 when n minus 2 is bigger or equal to 0, 2 to the n minus 1 when minus n plus 1 is bigger or equal to 0. So in that case, I can express this in terms of the unit step. So y of n will be 2 times u n minus 2, and then plus 2 to the n minus 1 u negative n plus 1. So that will be the answer. Okay, if you wanted to write it as a piecewise function, or you wanted to write it in terms of the unit step function. So that is the way that one way to compute the convolution sum graphically. So if you like my videos, please subscribe to my channel. Thank you.